2, 1. Hi, everybody. It is Steve Olson and Wayne. This is a breaking update. We have information and data from one of our physicists to help us understand what the new SECCHI images reveal about the sun simulators. Wayne, what are your first comments and thoughts when you saw this document today?
Well, I think it finally begins to bring some clarity and at least some sanity to the conversation. And Steve, I believe as the viewers would see as we go through this document, it clearly shows that this is not a lens flare. It's not an anomalous of the camera. This is really something.
Okay, so let's just start. So basically, the figure one. Here, I sat down today. I have not been able to hardly even produce material. It's been just content. So first of all, figure one shows the strange object appearing on the SREM detector, which we have learned is basically a highly charged electron, highly charged proton detector. It is not a light detector, and the people that are trying to convince us out there that this is some type of a flare are fools. Please stop listening to them. The symmetry and well-defined edges of this object suggest that it's not due to a naturally occurring phenomenon, but that it is a technological device. There appears to be a plasma discharge between the parabolic part of the device and the disc shaped part that would be the focal point of the mirror. If this was a parabolic mirror, or the collector, if this was a solar collector, this device also seems to be rotating from one image to the next. The time interval between each image is 2 hours, so the object is probably rotating quite slowly. Wayne, any comments on this?
Yeah, and that's one of the things that has really drawn me, particularly with this viewing. This object or its companions have made some number of appearances. But Steve, that's what got me, is that when you begin to advance the frames, it clearly looks like there is a reaction taking place.
Correct, and that's what we wanted to kind of point out to everybody. And then you look at figure one and figure two, and what our scientific help is telling us is that these images from the SREM detector on H1, this is the thing that everybody's been reporting on, in these different time intervals, showing what seems to be a plasma discharge between the part of the device and the shape of the parabolic reflector. And by the way, that was the thing that you and I were wondering about. I mean, we were in a sense of wonder when we first discovered Wayne. Remember that?
Yes, I do.
Gosh, that was it really impacted me to see that. Anyway, figure two is the solar collector, typical solar collector, showing the relative position of the parabolic reflector or mirror and the collector at the focal point of the mirror.
Look at that. And while I was looking at this, we can't sit here as lay people and say that we understand the science. Maybe this is a new propulsion system. I mean, who knows, Steve, right?
That is correct. And we're not trying to draw any conclusions right now. I'm just reading a paper, guys, okay?
All it is.
So figure three shows the object in question again, this time from a Steve Olson video that reveals some three-dimensional details about this object. In this image, we see into the interior of the parabolic reflector-shaped part of this device. This is also what seems to be a discharge emanating from the parabolic part of the device and hitting the collector. This is indicated in the right image of figure three.
Yeah. Well, we can see that as well, that it's having, a reaction to the light photons. I mean, listen, it's very clear. Look at that. The one on the left particularly, where the professor really does show the writing over on the right, and then you see the one without. Look at that. I mean, it's just very clear.
Thank God for gamma, huh? Gamma setting. All right, so the objects in figures 1 and 3 does not, however, seem to be collecting sunlight like a normal star collector would. This is where it gets weird. In order to do that, the inside part of the parabolic mirror would have to be pointed towards the sun, and that's what I was thinking as I was reading the first part. And here we see it turned almost completely away from the sun. However, the plasma discharges suggest that it's an energy collector of some type. The form of energy it is collecting is probably ionized particles in the solar wind. But since it is turned away from the sun, it is either designed to collect particles from the outside part of the parabolic reflector, or is collecting particles from another object? In which case, the disk collector part of the energy collector would be pointing towards the object it's collecting energy from. Now, just let's soak that in for a second, Wayne. Give me a color commentary while I pick my jaw up off the ground.
Yeah, so while I was hearing you read that, and I'm reading it myself, you know, I was drawn back. We're celebrating 50 years of Star Trek, the original series. But in Star Trek The Next Generation, remember they had a thing called tachyons. And that tachyons were, you know, particles. And I'm looking at this and I'm thinking to myself, what if you're actually collecting certain elements, certain particles that when condensed, like on the moon, we know that the moon apparently is covered with H3, which is apparently one of the most fuel efficient, and it's going to take us into the next level. So that's what I was thinking, Steve.
Thank you, because now that I'm able to tie my jaw back to my head. So here's the illustration of the various components for the energy collector, and I think it's pretty clear. It's a pretty simple, straightforward energy collector type scenario. Anybody that's ever seen science understands you collect with the dish, and then it points it to this little thing. Remember the old satellites in the day, y'all?
Oh, yeah, yeah, the old C-band.
Yeah, we used to do our, and that was what was happening there. That big collector was bouncing those TV waves up into your little collector, and we were able to get free cable for like a couple of years. Remember that, Wayne?
Oh yeah, and I'll tell you how well we got in the technology. We went from C-band to KU band, and we're finding out that you can condense this. So anyway, yes, sir.
Yep. So now the object is. So let's now see where this object is and what it's and where it's pointing to. From the H1 stars, an image on September 6th at 0009 UTC shown below, we can see that Venus, Mars, and Neptune are in view, and we can see their relative positions. So let's go ahead and suck in on that so we can show everybody what we're talking about. Here's figure 5, SECCHI H1 star A image on September 6th, 0009, showing the same view as the images in figure 1, and also the relative position of Venus, Mars, and Neptune. This really isn't bedtime reading, is it?
No.
No. So I agree, everybody, that that is what we are seeing, and that is what SECCHI has labeled. Yes. Okay. Thank you. Now, with the help of the solar system scope, we can align our view to fit the relative position of Venus, Mars, and Neptune, as shown in figure 5. This is shown in figure 6. So here's solar system scope, which we play with all the time, showing the same relative position of Venus, Mars, and Neptune, shown in the H1 stars A image, figure 5. So you've got Earth, you've got Neptune, Venus, blah, 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 right? And there's the orbit. Now, since the H1 spacecraft follows the Earth orbit, the energy collector is probably between Earth's orbit and Venus, which is what I kind of felt like too, just intuitively, and probably a lot closer to Earth's orbit than Venus. This means that the energy collector is pointing away from Earth and pointing to a position below the ecliptic.
Yeah, there we go again.
And for any new viewers out there trying to ascertain what's going on here, we have a physicist's thoughts on a recent observation. This channel is all about trying to track a star that has been prophesied to come into our solar system. And right now, what we're doing is we're reading this physicist's points on some of our recent observations. It's pretty interesting stuff. So, is it pointing to one of the stars that have come close enough to the sun to be seen from the Earth's surface during daylight hours? Wayne?
Mm-hmm.
Or is the energy collector pointing towards the brown dwarf star and draining the sun of its energy?
I'm sorry, I was reading ahead of you, and I'm picking my jaw up from it. So, yeah.
Read ahead now. Stay with me, Wayne. Stay with me. So one thing is for sure, this object is not acting like a sun simulator at the moment that the images were captured. A sun simulator would be facing towards the Earth. That's exactly what I was thinking. It would be that it has two functions, an energy collection function and a light source generation function, which would then turn it into a sun simulator at appropriate times. It is perhaps being used to collect energy from an object close to our solar system. Let me say it again. Is it perhaps being used to collect energy from an object close to our solar system? Is it an object that is perhaps a little below the ecliptic plane, as we've all heard? all of these possibilities are we must consider. We do have plenty of evidence that sun simulators are being used and that there are a few different sun simulator designs. Wayne, let me go to the next page while you just give us a little color.
Yeah, well, you know, listen, we're seeing these sun simulators, and I think there's a number of them. I really do. And we're seeing in some cases, such as what Michael Johnson showed from in New York on Friday, it just absolutely breaking down.
And Wayne, I know that I'm not trying to sound this is just amazing. This is just shocking. Okay, Figure 7. The object photographed from Earth's surface, which we saw that was from Occupancy, Addicted to Sports webcams, in the shape of a parabolic reflector emitting a bright beam of light. Figure 7 shows another object photograph from the Earth's surface. It has similar features to the energy collector in figures 1 and 3, but seems to be in emission mode. It seems to be firing plasma, or it may be using plasma to produce a strong light emission. With a strong emission like that, it may simulate the sun or the moon when turned towards Earth. The emission point seems to be a bit closer to the parabolic reflector part of the collection disk is to the parabolic reflector in the energy collection device. My God. So these are not the same object, but they are enough similar, and there are enough similarities between the two to suggest that they use the same type of technology to collect and emit energy. They are likely, therefore, to have an energy collection mode and a sun simulation mode. Therefore, I will call this device from now on an energy collector and sun simulation device, or an ECSS device. Hey, we have our own acronym now.
Well, that's what we're going to call this. And you know, Steve, I'm drawn to the drawing at the bottom because, as you know, the big thing in the late 90s and early 2000s was wiring the cities for fiber optics. I made a lot of money in JDUS, the Uniphase, Red Brick, a lot of them. Think about this. The reason why we went to fiber and why Lucent made so much money during that time is that we realized that we could put data pockets into photons. So is it so far-fetched to now take this to the next level in beginning to harness the energy itself? Just saying. And just think about the amount of data. I mean, this begins to open up a whole new world of when you begin to think about this. This is particle physics.
Well, and I thought it was interesting that that the professor actually points out that the explanation for this odd shape is because those are actually energy collector waveguides. And, you know, I've been in electronics all my life. I understand what a waveguide would be.
Yeah.
So I understand it. I get it. Basically, what it's doing is whatever energy is here, it's basically used as the collection node or point of contact with that, and it becomes basically an anode device and sucks the energy in.
So the ECSS device. All right, I'm right there. I'm on board.
So the fact that the beam of energy or light emitted by the ECSS device in Figure 7 narrows and then widens suggests that the beam goes through a focusing device or lens. The point where the beam is narrowest is the focus point of the lens. The central part of the beam goes through the lens undeviated, but the parts of the beam outside the central part are deviated towards the focal point and then diverge outwards after passing the focal point. Now, this is the illustration to help us understand. So Figure 9 shows this image of what we are supposed to think is the sun from the ISS, but it cannot possibly be the real sun. Wayne, you've been saying that all along.
Well, haven't I?
The sun cannot possibly show the kind of hexagonal symmetry that we see this light source has, or even produce hexagonal lens flares as this device does. The ECSS device in Sun Simulator operational mode can go some way in explaining the images of the simulated sun as seen from ISS, especially the peculiar circular outline of the device, shown in Figure 9 below. Again.
Look at that. Yep.
And so the dark circle seen in the image surrounding the light source can be explained as the parabolic reflector of the device. In Figure 7, or the device in Figures 1 and 3, the beams of light emanating from the center point could be parts of the beam seen in Figure 7, which diverge and go through the focal point.
Yep.
The image of the sun simulator device is photographed from the ISS, and that's what we just looked at. And then the shape we'd expect to see from the ECSS device in figure 7 when turned towards us in sun simulation mode is shown on the left in figure 10.
Look at that.
The image on the right in figure 10 is what we see from the ISS sun simulator.
We're catching you, NASA.
Yeah, I know, right?
You know, guess what? Our hamster wheel just doesn't go in a circle. It's a runway.
Yeah, we're taking a run at it. So, yep, just damn the torpedoes, Wayne.
Exactly.
So the difference between the two is the hexagonal shape of the ISS sun simulator light source and the square shape of the sun simulator's ECSS light source from figure 7 and 8.
Well, you know, that would make sense on the video I caught that day off the ISS, where we actually saw the sun, or the sun simulator, retrograding to the left. Now, it's never done that since then, but this would make sense.
Right. So to finish up the story, the kind of breaking story here, I think we need to get this information out. Please share it, please, with as many people as possible. Figure 10, the image on the left is what we would expect to see from in front of the ECSS device. That has 4 waveguides, 1 for each of the 4 points, thus making the source look square. The image on the left is what we would expect to see if 2 more waveguides are added. Now the light source looks hexagonal and shaped like the ISS simulated sun. Anybody want to debate it? Please make your notes in the comments below. Wayne, any final thoughts?
Listen, we're getting better at this. And I know this, Steve. I know, again, we will find the answers on this. And we'll find out what the powers to be. I mean, they're obviously monitoring us. We know that. So, hey, we're figuring this out, boys.
Yeah. And, you know, be sure to watch the last 2 or 3 videos to catch up to us. If you haven't seen those yet, it's really a story that's emerging and evolving. Compare this to more of a somebody who's presenting to you as they learn, and we'll learn together with you.
Yeah, and again, Dr. J, you're still giving me nightmares, man.
Me too, brother.